Welcome back. This is a teaching video on section 5.4, which is 3.4 in your textbook. This is on projectile motion. If I throw a ball or shoot a cannonball, it doesn't have a motor on it. So it doesn't have a means to have a force on it. And if there's no force other than gravity, then it's a projectile. So a projectile is anything you throw, and the only thing that's acting on it is gravity. So imagine if you were to throw a ball in space where there's no gravity. Whatever you throw it at, whatever the initial speed that ball has when it leaves your hand, it will always have that speed. It'll go forever in one direction at a constant speed, and it'll never stop unless it's acted upon by another force. If it's somehow bumps into a force field of a planet or a star or something, it can start accelerating. But if there's nothing to accelerate it, it will always go at the same speed. So if you have gravity, it's going to pull towards the center of the planet, in this case Earth. So if you have gravity, it's going to accelerate. So what you're going to see in projectile motion is you've got a very definite arc. You're going to have a parabola or a parabolic arc. Anybody that's ever thrown a basketball throws it in an arc, or a baseball in an arc. You never throw it straight. In fact, if you want to hit it straight, if you want to throw it straight like a baseball player has to throw it higher than it wants it to be, because gravity is pulling it down towards the ground. And so if it's going to go into the catcher's mitt, you actually have to throw it slightly higher. You aim higher than the basket when you're doing basketball for the same reason. So this slide, a horizontal component of the motion is just like the horizontal motion of a ball freely along a surface without friction. So imagine that the horizontal, or straight across, the x-axis of a graph is just like there was no gravity. If you throw a ball, it'll go at the same speed straight out as it left your hand. The vertical component is different. The vertical component is changing because the gravity acts down in a vertical direction. So you've got two different things acting differently. One going out, one going down. The one going down is accelerating. The one going out is not accelerating. And when you put those two together, you'll get that characteristic arc that you've always seen when you throw a ball. So a projectile is any object that moves through the air or space acted only on by gravity. So a plane would not be a projectile unless you cut the engine. Something that doesn't have a force on it other than the velocity it had when it left your hand or the cannon or whatever, only thing acting on it, the only force is gravity. That's a projectile. So projectiles near the Earth's surface follow a curved path. That's what we were mentioning before. So the path of a baseball is always in an arc. If you're throwing ball, playing catch, you always throw it in an arc, because that arc is straight across horizontally, but curving down because of the gravity acting vertically. So this would be a constant motion. If you roll a ball along a table and every second it's at the same distance from the last place, okay, then it's going at the same speed. 1 meter per second means every second it's going 1 meter further. So that would be a constant speed. When a ball leaves your hand horizontally, it's going at a constant speed. If you drop it, okay, so over here it's being dropped, you can see that the distances are not the same. This one's farther because it's going faster. This one's farther because it's going even faster. So a ball is getting increasingly fast as it goes down towards the surface of the Earth, because force is acting on it to change its motion. In this direction, since there's no way that it can go up and down, it continues in the same constant speed. So I drew some purple dots. This is the first purple dot here in the x direction, shows you that if there was no gravity at all, when you throw a ball, it's going to go a certain distance in a certain time and always be that same distance in the same time, and that's constant speed. So constant speed, or constant velocity, its velocity is constant. Okay, that's an arrow, okay, because it's a vector. The downward speed is going to increase because you have accelerated. So this is accelerated motion, okay, and so the velocity is increasing. So the velocity is increasing. So what is it going to look like? Well, in the same amount of time that it would have gone here, it's still going to go here, but it's going to be dropping, okay? So it's going to go here and drop and turn out to be here, okay? In the same amount of time that it would have gone here, it's still going to go that far, but it's going to drop, but it's going to drop farther, okay? Because in the same amount of time, the gravity acting downward is going to pull it towards the ground. Okay, so it's going to go the same direction. My dots aren't good. Okay, and then here, it goes all the way down to here. So you're going to get a characteristic arc, and that arc is a parabola. A parabola in math class is something to the squared. So x squared is going to give you, if you were to graph something that's x squared, you're going to get that very, very specific looking arc, okay? So the horizontal component and the vertical component are independent, okay? So that's why it would go sideways in constant speed, but downward at accelerated speed. So your job is to be able to describe the components of projectile. Can you separate them? The projectile straight out would be what? The projectile motion straight down would be what? And then could you draw that arc based upon what I've drawn for you in a minute? Okay, hope that helps you.